Hello, welcome to another episode of This Week in R, presented by the Hong Kong R User Group. And when this video hit YouTube, it should be February 6, 2017. And I'm your host, Cheng Saw. As always, I'm a member of the Hong Kong R User Group. Hong Kong R User Group is a small user group in Hong Kong, and you may find us on Facebook. And in this video, I will show you the latest development in R last week. So again, without further ado, we will start right now. So the first news is about our community, which is meaning the Hong Kong R User Group. So I have hints about it last week actually. So Hong Kong R User Group will offer a machine learning for beginner training course in March, and it is an 8-hour training course for the R beginners, so that you can learn the basic of R together with the machine learning in practice. So if you want to join, you can fill in the application form here, and we will announce the admission decision in February 15. So now, so okay. Apart from the news about the community, we have the news about R. So the first news is about a graphical user interface for R. So there are many graphical user interfaces for R, and there are many attempts to make R easy to use. For example, there are R commanders, there are deducers, and now we have a new one again, which is called a jamovi. I think it should be pronounced as jamovi. So they are available in jamovi.org, and you can download one. You can try. And actually, it's a graphical user interface similar to Excel or SPSS. It say that it is a free and open software to bridge the gap between researcher and statisticians. And the interesting thing is the computing engine of this software is R, and also it is free and open source. So and of course I have downloaded one and give it a try. Actually, it's not that bad, and as you can see from here, this is the user interface of jamovi. It's very similar to Excel or SPSS. Actually, I think it's modeled after SPSS, and you can enter data right away like this. And then you can have another, maybe quite one and two, assuming that we only have two groups, and something like that. Okay, I'm a SPSS user very long time ago, so I kind of know that how it works. So so now we have two variables, A and B, and actually we can do a t-test, for example, and compare the A with the grouping variable being B. I don't know. Yeah, it works, and it will print out a nice t-test result like this. And you can also have other tweaks. For example, you can have the descriptive analytics. For example, it have the mean and the median SD and all the descriptive analytics, and also the prod. Okay, when you look at the prod, you will know that it is basically R. So the prod is basically ggplot. So with just few click, we can conduct a very simple statistical analysis like this. So in most of the time, that is what the researcher want, and they can even copy these results and put it into the Word or something like that as a result, and then report it to your boss and something like that. And the interesting thing is this one. So you can enable the syntax mode, and if you give you the R code for generating these tables, so you can save these code for future use, and then you can use this R code in your ordinary R section. So it's kind of reproducible, so it's a nice thing. If you want to have a user interface, graphical user interface like this for doing your data analysis. So okay, currently there are not much functions available. For example, it only have some descriptive analytics, t-tests, some ANOVA, and also the very simple regression analysis. So, and also the cross tabulation and things like that. So very basic statistical analysis modules. So it can be expanded, but currently I think there's no expansion available. So interesting project, and let's hope that it will be developed further, so that we will have a very nice graphical user interface to use in the future. Okay, jamovi. And the next one is again about it's not a game. As last time we talked about Sparkly R, which is about big data, but this time we're talking about machine learning. So this is an analytic released last week, I think, and someone tried to analyze the data online and find out which package is the most popular machine learning package online by combining the data from CRAN, from Stack Overflow, and also GitHub. And they found that the most popular one is Carrot. That is what I expected, because most of the people use Carrot, because it actually includes basically all the commonly used machine learning algorithms. And then it have other machine learning package, which is individual algorithm, for example, the random forest, neural network, recursive partitioning, etc. And also GBD, which is a gradient boost, I guess it should be a gradient boost. And also Alvita is Alvika is a machine learning library for Java, and we have the R bindings to that Java library. And most interestingly, the 16th is H2O, and actually last week H2O released a new version on CRAN. The development of H2O is actually quite active, and they released the new version on CRAN. And so H2O is a mathematical engine. They claim that they are a mathematical engine, but actually is a machine learning library for, I think it's written in Java. So it's a Java machine learning library, And we have the official out interface to H2O, so that you can use the H2O in R. And actually H2O is not that bad, and the most H2O. So we can have a look, and it have the those commonly used machine learning algorithm, for example k-mean, general linear models, naive Bayesian, PCA, gradient boost, things like that. The most important one actually is deep learning. It offers deep learning it's offered that so that you can use it in R. And currently there are no if you're using Python, for example, you can use TensorFlow. And somebody tried actually RStudio tried to plot the TensorFlow into R, basically just R rubber to the Python, and then Python to the C++ TensorFlow, so that you can use TensorFlow in R. But you can also use the deep learning algorithm provided by the H2O. And I will show you, I will give a brief demo of how to use H2O to do a deep learning analysis using H2O. Okay, so this is our code, and you can install H2O using the regular install.package and then H2O, and make sure that you have Java in your machine, and if you're using a Mac, it should be built in. And when you install the package, it's not just only install the R package, it will fetch the H2O Java library online, and it will download it by itself, and it takes some time. And after you install it, you can just run it. And when you require H2O, it will tell you the next step is to initialize H2O instance, and then you can do the analysis. And let me try. I initialize a H2O instance like this. So H2O init, and it will start the H2O like this. Okay, it start the JVM, and then try to connect to that H2O instance, so that you can call from R. So I will use the most common dataset for doing deep learning, and that dataset is the MNIST dataset, which is the digit recognition dataset. And and I need to change the orientation first and put this in the top and the R console. Okay, this one. So, and I will download the training data online, and then download the test data as well, and then import that data into H2O. Actually, you can import a local file as well. For example, if you have a CSV file in your own machine, you can import a file using this. And also, if you have a data frame, you can just also import it into H2O using this. So I will try to import the data like this, because it is running, it's downloading the data online, so it takes some time, and it depends on your internet speed. So maybe in the video I will speed this part up a little bit, so that you don't need to wait for a long time. So it's importing the data. And now for the test set. So again, we have the training set and the test set data. So the train is a H2O frame, and you can reason H2O frame is just a data frame, but a data frame for H2O, and you can convert it to the regular R data frame later if you like. And what that data is okay, so it have 785 columns. So actually the first 784 columns are the data, and the last column is the label. So we can convert it into a vector, and you can see a bunch of number like this. So it's just numbers, you don't know what it is. So I can convert the first 784 elements into a 28 by 28 matrix like this. For example, I just want to convert the first row. So the digit is matrix right now, so I can plot that matrix using the digit matrix, and then using the image functions. And I need to specify, okay, the numbers in it, for example, these numbers is the grayscale pixel value. So, and I need to specify the grayscale color, and then you can have a look. Okay, it's look like a 5 or 2. So make it smaller. So something like that. It's okay. It's a handwritten digit, and I believe it's extracted by the U.S. Post Office, and they want to recognize the number written by their customer. So they have a large data set called MS, and this is the data. So they just extract the scan of the handwritten digit by their customers, and this one maybe 5, maybe 2, and so I don't know what it is. Maybe it's a 5 or 2. So okay, it say it's a 2. So you can have maybe the second row. So this one obviously is a 3. So that one should give me a 3. Yeah. So basically we have the pixels, and the pixel represent an image of the digit written by, is a handwritten digit, and also we have the labels, meaning the answers, the true answers, in the last column. Okay, so we will do the deep learning. So okay, we know that the last column is the answer, the labels. So we specify the y meaning the labels that we want to predict as the 785. So, and then we want to specify the rest of other columns as the feature matrix, and then we will specify the last column as the y, as a column called y, and then again it's actually converting that column into a factor. So you can have a look. So we look at the first one. Oops. Okay, anyway, it's a factor. yeah, is a factor. So oops, okay. And then now we can do the exciting part, which is using the deep learning algorithm provided by H2O to do the deep learning. And deep learning actually is just neural network with multiple hidden layers and also some specification of how to do the learning. For example, using different activator, and so actually it's pretty easy to use in H2O. For example, you need to specify the X being X, actually the column names, Y is the column names of the labels, and the training data is called a training frame, and then you specify to train, which is that we import from online, and also give it a model ID, and that hidden one is important. So you can specify the number of hidden layers, and also the hidden layers, how many nodes in that hidden layer. So may I have a graph? So for example, input, and then there should be some hidden layers in your neural network. It can be have multiple layers, and in each layer is have different log, and finally we have the output. And in the H2O you can specify, you can customize how the hidden layer configure it. So in this case, I just use 2020. It's just meaning 2 hidden layer with 20 nodes. So so I can just run it. It takes some time, and deep learning is slow. Okay, the training is slow, but if you're using the GPU enabled analysis, it can be very fast. And okay, in this case, I just have 2 hidden layer of 20 nodes, which is not the default value. The default value should be 2 hidden layer with 200 nodes. It will be very slow if you're using the CPU instead of the GPU. So, but anyway, I just want to test it and see how powerful it is. So I just use a very rough. Okay, the number of hidden layers, and also number of nodes in each hidden layer affect the accuracy of your analysis. So in this case, I just use 2 layer and 20 nodes. Obviously, it will not have the best accuracy. So, but anyway, this is just a test. So you cannot blame me for using a simple one. But of course, using a simpler structure, it will be faster. So okay. Now we have the DL fits one, okay, deep learning fits one, and we can even have the confusion matrix available. So for example, the all the 0 in the data, how many of them are correctly identified as 0? So in this case, most of them actually, the error rate is only 1%. So yeah, it quite accurate. Okay, and you can do the prediction using this H2O.predict. It will give you a data frame actually, and with the prediction and also the probability of falling into that category, and but in most of the time we will just use a predicted value. So predict y created. So these are the predicted values of the predicted by our deep learning model, and you can convert it into a vector. This is a R vector, it's not a H2 frame anymore. So you can also do the model evaluation using your test set. Remember, I just used the training set to do the machine learning, and now we are using the test set to do the performance evaluation. So with our model, DL Deep Learning Fits 1, with the new data being the test, and I use the H2O dot performance to study the performance of our deep learning model. And so you can calculate the MSE, which is the mean square error. Okay, no, not mean square error. It's just mean square error. Okay, so we can have a look at the error rate. Basically, smaller is better, and also the H2O dot confusion matrix DL path 1. It will give me the confusion matrix in the test set. So the similar things. Okay, and it's easy to train a deep learning model like this, but the difficult part is to do the tuning. Okay, as you can see, I've told you this is just a very simple deep learning model with just 20 layers, but with just 2 layers of 20 nodes, and we have and after that we have a model have an error of 0.46. It is not the best, but you can tune different parameters in the deep learning function provided by H2O to improve the accuracy. So, but that one very long, so I will not run it right now. So if you like, you can run it yourself and then see how the performance improve. Okay, so you can also have some plot like this one. So this one is what we call the error curve. For example, we find that and actually the deep learning algorithm is iterative learning algorithm. So after each epoch, the performance should be improved. So you can see that after the 2 epoch, the classification error decreased from over 9% to just over 0.5%, and then after 10 epoch is dropped to 3%, for example. So you can have a study of your model using this one. And this is a demo of the H2O, and actually there's not just H2O. And H2O also offers something more. For example, the H2O should have for example, the sparkling water. Sparkling water is the H2O for the spark. So you can use the spark that we have introduced last week with H2O, so that you can have a big data deep learning framework. And also deep water. Deep water is a preview right now. Deep water is the GPU enabled H2O module. So if you're using deep water to do the deep learning algorithm, it should be faster if you have a good GPU in your machine. Okay, that's all for this week and of news, and we will go to the next section, which is This Week in Our Tips. So this week in Our Tips is about a package called a stargazer. And okay, why I introduce stargazer and how it works. Okay, sometimes when you do the analysis in R, and you need to hand in a report in HTML or in for academics, for example in social science, and your boss may expect you to to turn in a report with Word, and if you use R to do the analysis, and then you need to turn in a report in Word, so in most of the time you just copy and paste the result, and then create a table in R in Word, and then plug in the numbers from R, and then copy and paste, something like that. But if you use the stargazer, you can make this part much easier. So let me show you how it works. So for example, I have a data set called ep2, okay, which is a data set of some performance rating, and also the number of campaigns and things like that for some individuals. I believe it's some employer analytics. And you can just use the stargazer attitude on that data frame. It will create something like that. Okay, you may not know what it is, but what I can tell you, that is the LaTeX code. Okay, for those in physics or in engineer, they write their report in LaTeX. So they can just copy and paste that LaTeX code, and then use the LaTeX interpreter. You can convert that into a very nice table. But we are not all engineers or work in physics. So for example, I can specify the type of output. For example, I can just say type equal to text. It will give me a table like this. It's just a very common summary statistic table of each column. So it says it have 30 case and a mean and standard deviation and mean and max. Okay, so you can copy this one into your Word, but that will be ugly. So I can try. So I can copy that, because it's just text, so that will be ugly. So okay, it will be something like that, exactly like what you see in R. It's nicer, but not as nice. Okay, so you can have the HTML version. Okay, after you run that, it will give you the HTML code similar to the LaTeX. You cannot copy and paste that HTML code into your Word. Okay, what you can do is to pipe that using the Magritte pipe, and pipe that into write nice function, and let's call it HTML attitude.html, and run that. So it will create a new file in your machine called attitude. So when you open it, it will have an HTML table like this, and you can copy this table and put it into R. Well, no, put it into Microsoft Word, and you will have a nicely formatted word table like this. Okay, so apart from this summary statistics table, like just use the stargazer, and sometimes you need to present your linear regression models in R, for example. In your Microsoft, I use R too much, so any software I will use the R label. No, sometimes you need to report your result as a Microsoft Word. Okay, for example, you have a linear regression model using the attitude data again. So I create two regression model, and if you know statistics, you will know that these two models are nested, meaning they have some common independent variables. For example, the linear 1 and linear 2, their common variables is complaint, privilege, and learning. And in the linear regression 1, we have wages and critical as well. So these two models are nested. Okay, and we can use the stargazer on these two linear regression model, and we can have something like this. Oops. We can have a nicely formatted table that compare the regression coefficient of two models, and also highlighted the regression coefficient which is statistically significant. Okay, and also the R2 and adjusted R2. These are the common statistics that most people expected for a linear regression model. And it's okay, but you can improve it even further. For example, now the independent variables are just called campaign and privilege and learning, things like that. You may not know what it is, so you can annotate the labels of these covariates using a character vector. For example, handling of campaign, no special privilege, things like that, and run that. And now the label change to the covariate labels that you have specified. Okay. And finally, you can do the same tricks. Pipe it to white lines and then export it as an HTML file. But you need to export it as HTML. And then open that HTML file in your browser and then copy and paste. So now you have a nicely formatted regression comparison table that look very nice in Microsoft Word. Okay, I hope that you find it useful, especially for those who are working in academics. Okay, once again, we the Hong Kong RUS user group, and I am your host, Cheng So. And this is for this week, and let's see you next week. Bye bye.